Now let's look at some additional features of the Visual Studio Debugger. So here is a modified example, and in this case we are still going to create a table of temperatures. So we're going to input the starting, the ending, the increment, and then we're going to use a function to calculate the values for the Fahrenheit and for the Kelvin temperatures. So in this code here, we're just going to print out the labels for the columns, and then we have our for loop. So the Celsius temperature will go from the start to the end, and it'll increase by that increment each time. But this time I'm calling a function called convert, and this will convert the Celsius temperature to Fahrenheit and to Kelvin. So if we take a look at that function, then here it is here, and you can see we'll pass in the Celsius, and it's called temp C here, and I'm passing by reference the Fahrenheit and Kelvin. So we'll calculate the temperature F, temperature F and temperature K inside the function, and those will be returned as reference parameters temp K and temp F back to the main program where they're called Fahrenheit and Kelvin. In this example, I'm going to want to show you how you can use the step into and the step out features of the debugger. So let's put some breakpoints here in our for loop for this. Okay, so let's put a breakpoint right there, and let's put a breakpoint at the end. Okay, so we'll have a breakpoint just before we call the function and at the very end of the loop. Let's also go down to the function convert, and let's just put a breakpoint in there as well. So we'll just put one right there. Okay, now we're going to run our program. Okay, so we're going to start it up, and then we have to type in the values. All right, so I'm going to type in 0 for the starting temperature and 100 for the end with an increment of 10 degrees. So this gets going, and now we have reached the first breakpoint. So we haven't called the function yet. We're at the breakpoint, and remember the breakpoint stops just before the line that it's on executes. So we've not actually called the function. At the bottom, you'll see we've got our window open for locals. Okay, so remember, if you look under the debug under Windows, then that's kind of off screen right now. But under that, you can get the locals option, and it shows you this window here. And I showed you how to do that in the previous video. So let's not go back and do that again. Now, look at the locals window at the bottom, and you see all those variables. We have Celsius, we have end, Fahrenheit, increment, K, and Kelvin, all those things. So those are local variables to main. So those are all those things here. Okay, I've also got an array of numbers, which we'll look at shortly. Now, the function has a few variables as well, right? It just has temp C, temp F, and temp K. And we'll see how those come into play shortly. Currently, we are inside the for loop, and we're getting ready to make the first call to calculate Fahrenheit and Kelvin. Under debug, and we can't see that, so let me scoot this over, and then under the debug, now we can see it. Remember, we have these three things. You can step into with F11, or you could use the F11 function key, or you could select it from here, step over and step out. So I'm going to step into the function. Okay, so let's see what happens when I do that. I'll select step into, and notice now that we have a little yellow arrow at the beginning of our convert function. We have stepped into it. And if you look at the locals, then we have the local variables for function convert. Okay, so how about that? Once you step into a function, your locals window will just show you the local variables of that function. Okay, so let's open this up a little bit more here. Well, I'm going to need to show you that menu, so I'll leave it like that. All right, now once we're in the function, we can step one line at a time if we want to, and that's the same as before. Okay, let's, so you can see the window. Here we go. Let's try it this way. Now you can see it. So we can step into, okay, if I do that, it just moves down one line. Okay, debug, step into again, it moves down one line. Now we have computed the temperature F, and you'll see in the locals window at the bottom it's red. So now our value for temp F is computed as 32. Then we're at the temp K line where we're computing the Kelvin temperature. So if I do a debug and I do a step into again, then we compute the value for the Kelvin value and we go to the bottom of the loop. All right, now I could hit, and I'll show you this. If I do debug, since we're at the end of the function, if I do a step into, then we come back out of the function and now we're back in the main program again. All right, so if you choose to step into, then you can trace each line within the function. So that's what step into does. Plus it switches the variables from the main program to the function that you see down here. All right, well, where are we? We have called the function and we have returned, but have we printed out anything? Well, okay, let's see where that window is. And the only thing we've printed out is just the headers, the Celsius, Fahrenheit, and Kelvin headers. So we haven't reached this cout statement yet. All right, so I can go back to the debug. I can do a step. It doesn't matter now. I could step into or step over, and I proceed to the next statement. So now we're at the cout statement. And if I do a step into again, then we go to the bottom of the for loop, and I have printed out the cout statement. So you see here's our first line of the table. Now, I'm going to go back to the top of the loop, and I'm just going to do that by doing a step into, and we're back to the top of the loop. If I do that again, I can do a step into or a step over. Remember, if I'm not at a line where we're calling a function, it doesn't matter if I do step into or step over. So now we're here. This time, I don't really want to go see all the calculations inside convert anymore. So I'm going to skip over it and just go on down to the cout statement. So this time I'm going to select step over. Okay, now since I've got a breakpoint in the function, it stopped in there. All right, so it went to the function and it stopped, but that's because I've got a breakpoint in there. All right, so let's take this breakpoint away. Now, while your program is in debug mode while it's running, you can remove the breakpoint just by clicking on it. So now it's gone. Okay, so now I'm going to hit the green arrow and we'll go back to the main program. Okay, now let's try this again. I'm going to do debug, I'm going to do step over, and I'm at the top. Okay, one more time, debug, okay, step over. So now I'm down here. Okay, now this time because I don't have a breakpoint within the function convert, then I'm not going to see what's going on in convert. Okay, so I'm going to debug, and now it's important. If I did a step into, I would go into the function. If I do a step over, I'll step over it. So here we are. All right, so I did not see the code for the function convert this time. The little yellow arrow just indicates I've moved down to the cout statement. So if you're using your debugger, then you have those options. Whenever you have a function that is in your program, you have the choice to step into it or to step over it. All right, so now we're in this loop, and you could continue to do this step by step. Okay, so I'll just do a step over for all of these things. Or if you don't want to do that, you can click the green arrow at the top, and it just takes you from one breakpoint to the next. Okay, so this will get us through a little faster. And as you can see here, we're just generating this table. Okay, so as I continue to go on, and let's see, I can probably leave a little bit of that on the screen. If I click here, well, no, you can't really see it all. But at any rate, then we will continue to go through this loop for the 10 times that we need. So I'm just going to click it. And notice in the locals panel at the bottom, you can see that new value for Fahrenheit is calculated and new value for Kelvin in red. You can see those as we go. Okay, so you can see those change, and we get through. Where are we now for K? Let's see, actually, where are we for Celsius? Okay, Celsius is at 60. All right, so we click again, it goes to 70, and we print it out. We go to 80, we print it out. We go to 90, and we print it out. Okay, so now our table is almost done. So let's click it one more time. So I'm going to click to go through here. And we're at the breakpoint, so I'll click that, and we're at the bottom of the for loop. Okay, so this is our last pass through the for loop. Let's look at the output that we have. All right, now, we haven't really seen a condition where the program has aborted, so we haven't run into any fatal conditions here, no abort errors. But you should always check to make sure you're doing your calculations correctly. And in this case, if we have some knowledge of the boiling and freezing points of water, then we know that 0 degrees Celsius is 32 degrees Fahrenheit. We might not know about the Kelvin, but that's okay. We also know that 100 degrees should be 212 degrees Fahrenheit, but it's 132 here. So here we have what we call a logical error. So this is indicating then that somewhere in our calculation we're not doing it correctly. All right. Now this is hard to pick up. Since we didn't have the program terminate, we're not at any particular point in the program that tells us, hey, you've done something wrong here. So we've got a logical error. The program runs fine, but it gives us the wrong answer. So you can use this debugger to help track it down. And if you brought out your calculator, then you could see what was going on. Let's look at the function convert, because that's what's doing the values this time. So if we look at the function, we could actually go in and we could compare the calculations that we get here with our calculations we do with a pencil and paper or with a calculator. Now, it may be hard to pick this out, but what's happening is that this 9 divided by 5 is what is wrong. That in C and C++, that's an integer divide. Okay, so it might be hard to pick this one up, but you know that something's wrong in here. Okay, the Celsius, let's just not worry about Kelvin, but the Celsius temperatures seem to be going just fine. When we look at the output, 0, 10, 20, all the way up to 100, that looks good. But when we compute Fahrenheit, Fahrenheit's not right. The first one is, okay, that one's okay, but all the rest of them are wrong. So if we examine that, then we know that when temp C is 0, this whole thing is 0. So then we get 32. But afterwards, when temp C is 10, 20, 30, 40, and so on, we multiply it by 9 divided by 5. But what is that? Well, that's 1, isn't it? If you do an integer divide, which is the default in C, it doesn't know any better, then that will give you an integer, okay? And look at that. If I hover over it, and you can see with the debugger, 9.5, the value is 1, okay? Not what we're expecting. So we can correct this, okay? So let's just do our 9.0, and we do our 5.0. So that would force this to be a real division instead of an integer divide, all right? So now we need to recompile the program, so we'll need to stop what we've got here, and then we'll run it again, and we'll check our values. All righty, I've recompiled the program because I did find the error. So now if I put in 0 as the start, if I put in 100 at the end, and I put in 10 as my increment, then I reach the breakpoint again. And actually, I don't want to go through all of those, but let's just go into our convert function, and let's see if it's working okay now, all right? So the first time through, that's Celsius is going to be 0. Okay, if I see that, that's 0, so I know that one's going to be okay. But let's do a debug, and let's step over that. So you can't see it, but I'm selecting step over. So I'm going to go past the function code itself. We'll go to the cout statement, and then we'll go back to the top of the for loop. This time, I'm ready to call the convert function. I'm going to do a step into. Okay, step into. So now we're in here, and I am going to go step by step. So to do that, we can use the F11 key or the F10 key. Okay, so here we go. We have the temperature for C is 10, the Fahrenheit's 32, that's correct, and temps K is 2273.15, that's correct. So now let's compute a new value for the Fahrenheit. Okay, I'm on this line and I'm ready to compute temp F. So I'll do a debug and I'll do a step into, and now I've computed it. All right, so now the value for temp F is 50. All right, now that is correct. You can take out your calculator and you can verify that that's the case. Okay, previously that was going to be just a value of 20. Okay, well, I'm sorry, it would have been 10. Temp C was 0, and then temp C with 10. 1 times 10 is 10, and 32 gives you 42. But this time we are getting a correct multiplication factor, 9/5 times the temp, and our temp F temperature is going to be 50 degrees. All right, so now we've corrected that problem. Now, now that that's done, I'm going to go back and I'm just going to remove these breakpoints that we have in the for loop for that. Now let's look at how the debugger handles an array. Let's look at how that looks. I've got this array declared integer numbers, and it's initialized to 20, and it's all set to 0 here. And if I, after we've done the example that I just showed you here with the temperature table, I've got a little for loop here that's going to initialize this array numbers with random values. Okay, so the rand function generates a number between 0 and 32,000 something, and the modulus operator is going to, the modulus 100 is going to restrict those numbers to be 0 to 99. So we have a breakpoint here at the beginning of the for loop and a breakpoint here where we're initializing the value for numbers. So let's just run the program and let's look at how the debugger can be used to see the elements of an array. So I'm just going to start the program here, and since we have to go through the temperature table first, then I'm going to go ahead and type in the numbers that we just did for it, and we will get the table. Then we are here at the beginning of the for loop to initialize the array. Now, a couple of things that you can do. You can hover over the array here, and you can see that you get the variable numbers, and then you get some big hexadecimal number there, which you can ignore. It represents the address of the first element, but that doesn't really mean a whole lot to us. But inside the curly braces here, you can see that we have all of those 20 numbers that are in the array numbers. They're all zeros, which is what we would expect. You can also, you can click the little arrow here, and it will give you a more expanded view of each element. So here's index 0, and if you scroll down all the way up to index 19. So it gives you the index, it gives you the value on the right-hand column. Okay, so as we go through this loop, the breakpoint is going to stop here at numbers at this line, and then it goes back to the top. Now I could do the function keys here, I could step through, but since I've got a breakpoint at the top and a breakpoint here, I can just use the green arrow just repeatedly. I can click that, and I can go through and see the values easily. So you can see it move through you can't really see it moving. Okay, I'm at the inside the loop now, so I'm going through this loop repeatedly each time I click the green arrow. All right, so I've clicked it for 3 more values here. So you can see in the locals the value for little k. Okay, the big K we had previously, we used that for Kelvin. All right, so we have little k here as our index that we're using for numbers, and if you hover over the value k, you see it's 3 up there. You can also see that it's 3 down here. If we look at the table, then here's numbers. Okay, numbers now has a value 41, 67, and 34. And if you want to open it up in the locals panel, you can do that too. You can click the little triangle here, and you can see the elements of numbers down here as well. So you have several options as to how you can inspect the elements of an array. All right, I'm just going to click the arrow a few times, and you can see the numbers change. Okay, that didn't show you much, but actually that value came out to be 0 for 3. So if you look down here, you can see those numbers change as I click the little green arrow at the top. Okay, so index 5 gets 24, 6 gets 78, and so on. So each time I click the green arrow, we generate a new random number and it's stored into the array. So if you are wanting to use a debugger to inspect how your array contents are being handled, it's very easy to do. So you can do it with this locals window, or you could do it here. And remember that you can also pin this thing to the screen, and you can see the numbers up there too. So it's quite easy to see the values. And as I click to go through the loop, you can see them changing and being initialized as we go. Okay, so it's only 20, so I'll just keep on clicking. 81, 27, I'm up to index 14, 15, 16, 17, 18. The last one's 19. All right, now I have a function here that will print out the array. So I am going to put a breakpoint there, and I'll put a breakpoint right before the end of the program. Okay, so we can inspect this as we finish up this little example. Okay, so if I click this one more time, then I'm going to exit the for loop. Okay, so now you see we are down here where we're calling print array. I could do a step into to look at what print array is doing. And if you wanted to, certainly you can. You just choose the step into function. And I tell you what, I'm going to do that one more time here because I'm not sure I showed you how to do the step out. So let me squeeze this down, and I'm going to go up here. I'm going to, under debug, I'm going to do a step into. All right, so now I'm inside the print array function, and I could step line by line. I could do the step into here. You can see it goes down one line, and repeatedly I could keep doing a step into. I could add breakpoints here if I wanted to. But if you have seen what you need to see inside your function and you're done with it, then you can choose just to go back at any point. Okay, so we can do under the debug window, if I do a step out, then it will leave the function and go back to the main program. Okay, so now we're out of the function, we're back here. So we have the step in, the step over, and the step out options when you're doing a trace with the debugger. All right, now I'm going to go ahead and I'm going to call print array this time. So I'm going to just do a step over this time. So step over, we get past it. Let's look at the output. So here are my 20 random numbers down here. Okay, so that was what we produced. And we can print them to the screen, and then we can also see them in the panel here. So you can see all of the numbers that went into our local variable numbers. And finally, you can see them up there on the screen as well. All right, so you have a lot of options. All right, so that will allow you then to inspect the elements of an array. So that shows you how the debugger does that. Now this is the only example, or the last example in this program. So let's just go ahead and finish up the program. And if we're done, we can clear all these by clicking them if you want to. We can clear all those breakpoints. But if you're done with it and you want to just clear the breakpoints so they'll not be there the next time you run the program, then you can, under the debug, you can go up here and you can disable all breakpoints. All right, so just click that. And it says, do you want to? And yes, I do. So now they're all gone. So next time we run the program, it isn't going to stop anywhere. So I'll click green, and now that will finish up our program. Okay, our program is now all done. Okay, so if I go over here, then we're at the end, and we have the usual Microsoft Windows way of saying that, hey, we're done, press any key to continue. That's what the last line in our program did, our system pause. So then I do that and we're finished. Okay, so then this is how your debugger would be used to inspect an array. To complete this video, let's look at how the debugger would handle some text information. So here's a little program that's going to allow us to type in a sentence, and then we're going to reverse the sentence. Okay, so to begin with, let's see, I've got a comment here. I want to actually put in an erroneous thing, and that's a CN statement. And it might be very easy to do this since we're so accustomed to using CN, but you know that you can't read in spaces with CN. But if we make this mistake, then the debugger can help us out. So the program is going to ask us to enter a sentence. Okay, then we don't really need to print this out again if we're going to use a debugger, but we'll leave it there. And here's a little loop that's going to print out the sentence backwards, just letter by letter. So this little while loop is going to do that. So we have a breakpoint here after we've entered the sentence, and we have a breakpoint here that's inside this loop. All right, now let's run the program. We'll be prompted with the output window here to enter a sentence. So here is the prompt, which will show up eventually. There we go. All right, so I'm just going to type in some sentence. The weather here is nice today. All right, so that's a sentence. All right, so then when I hit enter, then we get the first breakpoint. Okay, so the breakpoint is here. We can hover over sentence, and here we can see that the sentence only contains the word the. So this would give us a hint that we have done something wrong. Since a string variable is actually an array of characters, we can also see this represented as an array. Okay, so here you see index 0 is to T, index 1 is H, index 2 is E. So we can break it out like that if you wanted to. And if you're looking at the locals window down here, then here is the sentence. It shows you the word the. And you can also hit the little arrow on the left, and you can see it also broken out letter by letter here. This number that shows up, here's index number 0. We have the number 84. We have the letter T. So that number 84, that's just the ASCII code for an uppercase T. Okay, the 104 is ASCII code for the letter H, and so on. So you can use the debugger to inspect some string information that you've typed in. But this would tell us, if we were using the debugger to try to figure out what happened to our sentence, then this would tell us pretty clearly that we are using CN and we only picked up the first word. So then we can go fix that. All right, so I'm going to go fix that, and I'm just going to replace it with a getLine statement. I replaced it with getLine and I recompiled, and then I ran the program. So we are going to type in our sentence again. So we have the prompt, and I'll see, the weather here is nice today, period. All right, so there's a sentence again. So then when I enter it, we get to the first breakpoint. Now this time we can hover over the sentence and we can see the weather here is nice today. That's great. We did read in everything we wanted to. If you look at the locals window at the bottom, you can see as well the weather here is nice today. And if you wanted to see it letter by letter, you could expand this and you can see all the letters here in the array form along with their ASCII values. So you have many ways that you can look at it. So that's one good thing. Whenever you're inputting information, it's a good idea to either print it back out again or just use a nice easy breakpoint, and you can investigate what was read in by your computer program. Now let's move down here and let's go through this loop. So the loop is going to output the letters in reverse order. So we're going to get the position, which is going to be the length of the sentence minus 1. So that'll give us the position of the last letter in the sentence, which in this case would be a period. And then, while the position is greater than 0, we're just going to take the letter at that position, the far right position, and we're going to concatenate it onto this esetness, which is sentence spelled backwards. And that's going to take letter by letter and apply it to this. Now, as we're going through the while loop, I've got the breakpoint in here so we can see how the reversed sentence esetness, that variable, changes as we go through the loop. So I'll press the green arrow and we'll move down here. And to begin with, you can see, and I'll collapse that, the beginning value for the reverse sentence is a blank, and then the sentence is this. So we'll pick up the period first. So when I click the green arrow, then you can see that esetness is now a period. So we can see that right there. And as we go through, watch that line. Okay, watch this line right here, and you'll see the letters are picked up. Okay, so we get the Y. Okay, the last word is today, period, right? Okay, so we get the letters today backwards that it show up here, and we get the position 24 as well. So as we keep going through this loop, and I'm clicking the green arrow to do that, then you can see exactly what's happening with the variables that you have in your program. And the only one that's changing here is the reversed sentence variable setness, as well as the position is changing. Okay, so it looks like it's doing pretty good. All right, so there's nice spelled backwards. So it looks like it's plugging along and it's going to reverse the sentence just fine. So let me just keep going here. I'm going to keep clicking. There is, okay, here. Okay, then we're going to get the weather that's spelled backwards. And then finally the word the, T-H-E. Okay, so we press that. And then, then look what happened. Okay, I have this error popped up. Okay, exception, out of range at memory location. Again, that not really a good message to help us figure out what's going on. But we have our local variables that we can look at. Okay, here is the sentence. Okay, we didn't change sentence, so that's fine. Here is the backwards sentence. That looks pretty good too, but wow, look at the position. Position became this huge number somehow. And we know that the index isn't going to be that big. All right, so the index is going to start way over here at this dot, and it's supposed to go back towards 0. But when it gets over towards the 0 point, it gets to this huge number. So something's wrong there, and our debugger can help us to detect what went wrong. So position would be this big number. How is that possible? And it may take a little bit of exploring to figure it out, but you know that's what's wrong. All right, so let's close this, and let's examine the program here. Now, notice that we are decrementing we're decrementing position. So position starts out with some number, 24 or so, I forgot what it was, and it gradually gets lower and lower and lower. Now, the last time through, okay, position greater than or equal to 0. Okay, 0 is a perfectly good index. If we looked at a sentence and we expand it, we see that index number 0 is fine and it contains the letter T. So we do want to go back to 0. But notice what happens after we do that. Okay, once we have the position at 0, then go away there, we decrement it, and it becomes that number. Wow, so it should be -1, so why do we get such a big number here? All right, well, again, it may be hard to really track this down, but the answer is this one. Let me show you. I declared it to be an unsigned integer. Okay, if I make a variable an unsigned integer, it's not allowed to go negative, is it? So I made a mistake here. If I want to use this loop in order to reverse my sentence, then position has to go to -1 at the very end. So my solution here would be to take away unsigned and just make that an ordinary integer. Okay, so that's the answer. But let's do this one more time. I'm going to go back and I'm going to put unsigned integer back in there. And I'm going to take away these breakpoints. I'll take away that one, and I'll take away that one. And also I'll close that out if I can. And I'll stop the program. So typically what will happen is you're writing a program. You run your program, something bad happens. How can the debugger help you to find the problem? I've not put any breakpoints in here. So let's see what happens. If I run the program, let me rebuild it. I'm not sure I need to rebuild it, but I will. So I'm going to rebuild it, and then I'm going to run it. And I'll type in the sentence. Okay, weather here is nice today. All right, and then I'll type that in. And look, here I have this error again. So one thing that happens is it puts this marker, this circle with an X in it, it puts that at the line that it thinks is a problem. Well, it turns out that really is a problem. But the debugger is going to give you that. Look, it gives you what the value of position is. And if you happen to have your locals window open, you can also see the values down here. So even though I didn't have breakpoints, if I've opened up my locals window so I can see the local variables, when the program aborts, I can get the values of everything when the program aborted, and I can see that position is what's wrong here. All right. Then, again, it might be a little bit difficult to figure out how to fix it because this is kind of a subtle error, being an unsigned integer versus a regular integer. But that's the problem. Okay, so then I'll take that off. Then I'll need to recompile the program and run it. And I'll just do that quickly. So I'll recompile it, and I'll run it again. And this time I've changed that unsigned integer to a regular integer, so that means it can go negative. And I'll go ahead and type in my sentence. Okay, the weather here is nice today. And then everything works out okay. Okay, so here's the reverse sentence, and I didn't get any abort errors, so everything is okay now. All right, well, at any rate, that's a little bit more of an exploration of the debugger. So if you go to the debug window, then you have a lot of options that you can use. I only covered a few of them, but those that I did cover will help you to analyze what's going on with your programs and hopefully help you to reduce the amount of time that it takes you to debug your programs. So we'll terminate the video here.